Good day, everyone. I'm Sharmeen Bonifacio from BSIT 21, and I will discuss the first come first serve or CFS scheduling algorithm. What is first come first serve method? It is an operating system scheduling algorithm that automatically executes queued requests and processes in order of their arrival. It is the easiest and simplest CPU scheduling algorithm. In this type of algorithm, processes which request the CPU first get the CPU location first. As a process enters the ready queue, its PCB or process control block is linked with the tail of the queue. And when the CPU becomes free, it should be assigned to the process at the beginning of the queue. Characteristic of FCFS method. It supports non-preemptive and preemptive scheduling algorithm. Jobs are always executed on a first-come, first-served basis. It is easy to implement and use. This method is poor in performance and the general wait time is quite high. Example of FCFS scheduling. A real-life example of the first-come, first-served method is buying a movie ticket on a ticket counter. In this scheduling algorithm, a person is served according to the queue manner. The person who arrives first in the queue first buys the ticket and then the next one. This will continue until the last person in the queue purchases the ticket. Using this algorithm, the CPU process works in a similar manner. So here's an example. Calculate the average waiting time and the average turnaround time if the first come first served scheduling is followed. Consider the set of three processes whose arrival time and burst time are given below. So here's the three processes, their arrival time, and their burst time. So in order to get the average waiting time and average turnaround time, we need to get the start time, waiting time, finish time, and turnaround time. And in order to get that, we need to create a Gantt chart. So what is Gantt chart? A Gantt chart is a useful graphical tool which shows activities or tasks performed against time. It is also known as visual presentation with project, where the activities are broken down and displayed on a chart which make it easy to understand and interpret. So first, let's create a Gantt chart. So as there are three processes, let's create a three column. The process begins with 1 or P1 which has an arrival time of 0. It has a burst time of 10, so 10 plus 0 equals to 10. The next one to arrive is process 2. Its burst time is 7, so 7 plus 10 equals to 17. The last one to arrive is process 3. Its burst time is 8, so 8 plus 17 is equals to 25. Now that we have the Gantt chart, we can create the starting time, waiting time, finish time, and turnaround time. So the start time, we can get it on Gantt chart. The start time of process 1 is 0. The start time of process 2 is 10. The start time of process 3 is 17. Now that we have the start time, we can now create the waiting time. And the formula for getting the waiting time is start time minus arrival time. So the start time of process 1 is 0 and its arrival time is 0. So 0 minus 0 equals to 0. The start time of process 2 is 10 and its arrival time is 1. So 10 minus 1 equals to 9. The start time of process 3 is 17 and its arrival time is 4. So 17 minus 4 equals to 13. Now that we have the waiting time, let's move to finish time. We can get the finish time from the Gantt chart. Starting from the process 1 ends with 10. So the finish time of process 1 is 10. The finish time of process 2 is 17. So it's 17. And the finish time of process 3 is 25. Now that we have the finish time, we can now get the turnaround time. The turnaround has a formula of finish time minus arrival time. The finish time of process 1 is 10 and its arrival time is 0. So 10 minus 0 equals to 10. And the finish time of process 2 is 17. 17 minus 1 is equals to 16. The finish time of process 3 is 25 and its arrival time is 4. So 25 minus 4 equals to 21. Now that you have the waiting time and turnaround time, we can now get the average waiting time and average turnaround time. So the 3 waiting time is 0, 9, and 13. Let's add it first, and 0 plus 9 plus 13 is equals to 22. As there's our 3 process, so 22 divided by 3 equals to 7.33. So the average waiting time is 7.33. Now that we have the average waiting time, let's get the average turnaround time. That the turnaround time is 10, 16, and 21. Let's add it and we'll get 47. So 47 divided by 3 process equals to 15.67. So the average turnaround time is 15.67. And that's how we get the average waiting time and the average turnaround time. That's all. Thank you for listening.
Good day everyone. Today I will discuss po the shortest process first algorithm or shortest job per scheduling. My name is Jenny Real Jucales from Bsit 21. Now, shortest process first algorithm or shortest job first scheduling is an algorithm associated with each process of the length of the process next to CPU burst. When the CPU is available, it is assigned to process that is being smallest next to the CPU burst. A more appropriate term for this scheduling method will be the shortest next CPU burst algorithm, because scheduling depends on the length of the next CPU burst of a process rather than its total length. So here's the example problem. Consider the following set of processes with the length of the CPU burst given in the milliseconds. As you can see here, we have a 4 process ID and their respective burst time. From the word itself, shortest job burst or shortest time process, we will find the smallest burst time, which is the P4. So P4 will be the first one to be used, the CPU, and P4 will end the execution in 3 milliseconds. So since from the word itself nga, hanapin natin ang next na pinaka smallest sa burst time, and that will be P1 na may burst time na 6. So siya na, si P1 na ang magagamit ng next sa CPU. So we just only need to do is add. So 3 plus 6 is equal to 9. So 9 milliseconds before na execution ni P1. So and so forth. So the last two will be P2 and P3. Since mas maliit ang burst time ni P3, si P3 na ang gagamit ng CPU. And so we'll do the math. 7 plus 9 is equal to 16. Mag-e-end ang execution ni P3 ng 60 milliseconds. And lastly, si P2 ang pinakahuling gagamit ng CPU o mag-run ng CPU rather. And so, simple math, 16 plus 8 is equal to 24. So, in order to find our average waiting time, we just need to see their respective waiting time for each process ID. This problem has no arrival time since this is just an example. But there will be an arrival time that will be discussed later on by our next groupmate. Now, for the waiting time for P1 is 3 milliseconds. Here's the P1, and P1 will run the CPU after 3 milliseconds. And so P2, waiting time for P2 is 16. The same with P3 with the 9 milliseconds. And lastly, with the P4 with 0 milliseconds. Since yung P4 pang pinakaunang gumawa ng CPU, hindi na po niya kailangan maghintay ng arrival time. So, to calculate or to solve this average waiting time, all we have to do is add the waiting time for each process ID, which is 3 plus 16 plus 9 plus 0 divided by 4, or kung ilan ang process ID nyo or process nyo, is equal to 7 milliseconds. This problem is example of a non-primitive, which means hindi po magagamit ng next na process kung hindi pa tapos yung unang gumagamit ng CPU. That's all for today. Thank you po.
Hello everyone, my name is Inati Agulto. I'm from Bsit 21 and the next topic is shortest remaining time first. So first, what is shortest remaining time first? Shortest remaining time first is the preemptive version of shortest job first scheduling. With the help of SRTF algorithm, the process having the small amount of time remaining until completion is selected first to execute. So basically in SRTF, the processes are scheduled according to the shortest remaining time, just like in the SJF or the shortest job first. However, the SRTF
Please try again.
However, the SRTF algorithm involves more overheads than the shortest job first or SJF scheduling, because in SRTF, OS is required frequently in order to monitor the CPU time of the jobs in the ready queue and to perform context switching. Also, in the SRTF scheduling algorithm, the execution of any process can be stopped after a certain amount of time. On arrival of every process, the short-term scheduler schedules those processes from the list of available processes and running processes that have the least remaining burst time. After all the processes are available in the ready queue, then no preemption will be done, and then the algorithm will work the same as SJF scheduling. In the process control block, the context of the process is saved when the process is removed from the execution and when the next process is scheduled. So we have the example P1, 2, 3, 4, and 5, arriving time and burst time. So meron tayong 0 which is the P4. Ilagay muna natin siya sa ready queue. P4, then i-transfer natin sa Gantt chart. Then 1. So dahil kumain siya ng isang unit, i-minus natin si P4 sa burst time niya, which is 6. So 6 minus 1 is equals to 5. So next, sino yung may number 1 sa arriving time? Sino yung unang umarrive, which is si P2. So ilalagay natin siya sa ready queue, P2. And then pag dalawa na sila sa ready queue, ipagko-compare natin silang dalawa, si P4 and P2, ayon sa kanilang burst time. So P2 is equals to 5 and P4 is also equals to 5. So dahil pare silang 5, para maiwasan natin ang pagiging komplikado, ipaparehas na lang muna natin siya kay P4. Then next is 2. So sino yung pangalawa sa arriving time? Si P1 and si P5. So ilalagay muna natin ulit dito si P1 and P5. And then ibabawas muna natin to si, so dahil gumamit ng isang unit, ibabawas natin si P4 ulit. So 5 minus 1 is equals to 4. So dahil nga nabawas na, update na natin siya, pupunta ulit tayo dito sa ready queue, i-compare natin tong apat kung sino sa kanilang apat yung pinakamababa sa first time. 1, 2, 4, and 5. So P1, 2, 4, and 5. Sa kanilang apat, si P1 ang pinakamaliit. So lalagay natin si P1 dito. Then, so, dahil nga nakalagay sa burst time ni P1 ay is number 1, so ibig sabihin, isang beses lang siya pwedeng i-execute. So, ang gagawin natin is, ite-terminate na natin tong si P1 kasi isang beses lang daw siya pwedeng i-execute. So, P1 is terminated na. So, next is pagko-compare natin. So, ipagko-compare natin si P2, P4, and P5. 2, 4, and 5. So, P2 is equals to 5, P4 is equals to 4, and P5 is equals to 3. So, sa kanilang tatlo, si P5 ang may pinakamaliit na burst time. So, sa kanilang tatlo, si P5 ang may pinakamaliit na burst time. So, lalagay natin si P5 dito. Then, next. So, dahil kumain din si P5 ng isang unit, ima-minus natin siya. I-update. 3 minus 1 is equals to 2. And then, tingnan natin kung number 4 na. May number 4 sa arriving time, which is si P3. So, ilagay din natin ulit dito si P3. And then, so, ipagko-compare natin silang apat kung sino sa kanila yung may pinakamaliit na burst time. Si P2, 3, 4, and 5. 2, 3, 4, and 5. So, sa kanilang apat, si P3 ang may pinakamaliit na burst time, which is 1. So, lagay ulit natin dito si P3. Number 5. So, dahil kumain siya ng isang unit, matutulad siya kay P1, mateterminate siya kasi nga, pare silang 1 lang, na isang beses lang na pwedeng i-execute. So, P3 is also terminated na. Okay, terminated na si P3. Then, yung natitirang tatlo, kung mapapansin nyo, yung natitirang tatlo, pagko-compare ulit natin sila. P2, 4, and 5. 2, 4, and 5. So, 5, 4, 2. Sa kanilang tatlo, si P5 ang may pinakamaliit na burst time. So, next. Kaya tinerminate natin ng isa. Kaya, pero kung mapapansin nyo, lahat ng ating process ay nandito na sa may ready queue. Meaning, lahat sila nag-arrive na. So, pag ganyan, na lahat sila nag-arrive na, pwede na tayong bumasi ulit sa SJF. Non-permitted. So, gagawin natin yung process ni SJF. Sa kanilang tatlo, 2, 4, and 5. Sino may pinakamaliit na burst time? 2, 4, 5. 2, 4, and 5. So, si P5. Para malaman yan is 2 plus 5 is equals to 7. Determinated na si P5. So, 2 and 4 na lang. Sa kanilang dalawa ay mas mababa ang burst time ni P4. So, P4. Then, 7 minus 4 is equals to 11. Then, ang natitira na lang is si P2. So, P2. Then, 11 plus 5 is equals to 16. So, you see, may pagkakaparehas siya kay SJF. So, ginagamit lang si SRTF pag masyadong komplikado sa overhead. But, pag nakita nyo na lahat ng process ay nandito na sa may arriving time, lahat sila ay nag-arrive na, nasa ready queue na silang lahat, pwede na tayong mag-proceed using the SJF algorithm. So, ayun lang po. Thank you.
My name is Kari Abelin R. Duterte, and in this video, I'm going to report the round-robin algorithm. Round-robin algorithm or CPU scheduling algorithm, it is in which the processes are selected on a first-come, first-served basis. Each process is given a time limit to execute at the CPU. Ibig sabihin, meron lang limit yung isang process para ma-execute siya sa CPU, then after, lalabas na siya. Then yung susunod sa kanya na process, and then the time limit na tinatawag is the time quantum. For example, let's say na meron tayong CPU, then meron tayong tatlong processes. For example, meron din tayong quantum time na 3. Ang mangyayari is, si process 1 mag-execute or pupunta siya sa CPU ng 3 minutes, Then lalabas siya after. Tapos ang susunod na si P2 and so on and so forth hanggang matapos yung execution ng mga processes. So, in this video, meron tayong example ng round robin and meron na rin tayong 5 processes na may CPU burst in each processes. And meron tayong time quantum na 4, then meron na rin tayong Gantt chart. So, the first thing to do is, syempre dahil first come first serve ang round robin, ang uunahin natin is si process 1 na merong CPU burst na 8. Pero dahil ang time quantum natin is 4, 4 lang ang gagamitin natin sa CPU burst niya. So, here. Mag-end siya sa time na 4. Meron pa lang 0 dito. Then, at dahil nga 4 lang yung nakuha natin sa CPU burst ng process 1, i-minus natin siya sa 4. Then, meron matitira na another 4. Then, after that, syempre, magpo-process na si process 2 na merong 4 CPU burst. Sakto siya sa time quantum natin. So, kita ko siya sa 8 seconds. Then, after nun, ma-finish na siya, may execute na siya kasi nga, yung CPU burst niya is sakto sa time quantum. Kasi 4 minus 4 is equal to 0. So, check na siya. Burado na siyang process. Ibig sabihin, done na siya and executed na siya. Then, the next one is the process 3 na merong 5 CPU bursts. Dahil meron tayong time quantum na 4, 4 pa rin yung masusunod kahit na 5 siya. Matatapos siya sa 12. And 5 minus 4 is equal to 1. Meron pa siyang natirang 1. Then, proceed na tayo sa process 4. Dito guys, nakita nyo yung process 4, meron siyang CPU burst na 3 lang. So, anong mangyayari dun? Siyempre, susundin pa natin yung time quantum na 4. Porket hindi niya na-meet yung time quantum na 4, hindi na siya magpa-process. Magpa-process pa rin siya, pero ang kukunin lang is 3. Then, magtatapos siya, yung 12, magtatapos siya sa 15. Kasi, 12 times 3 is 15. So, ayun, edi cancel na siya kasi wala nang matitira sa kanya. Wala na tayong isi-solve yun kasi kulang na siya sa time quantum. Then, the next is process 5. Kung nakikita nyo dito, mas maliit yung CPU burst niya kasi sa process 4. So, kahit ganun, ipaprocess pa rin natin siya. Magtatapos siya sa 17. So, done na rin siya, executed na rin siya. So, dahil nga first come, first serve ang round robin, babalik tayo sa process 1. Babalik tayo sa process 1 na meron pang natitirang 4. Then, process 1, mag-run siya and mag-execute siya and mag-end siya sa 21. Kasi sakto siya. Yung natira na 4 dito, sakto siya sa time quantum na 4. So, matatapos na rin siya kasi executed na siya lahat. Then, yung natira is the process 3 na merong natira na 1. So, ayun, napakaliit din ng CPU burst niya. Pero magpa-process pa rin siya, guys. Then, matatapos na to 22. Yun, tapos na natin lahat. Na-executed na lahat ng processes. That's all. Thank you.
Good day, sir. My name is Alisa Jin Maisa from BSIT 21, and I'm going to talk about the multi-level feedback queues. First is the scheduling algorithms. The idea is to separate processes according to the characteristics of their CPU burst. If a process uses too much CPU time, it will be moved to a lower priority queue. These schemes leaves IO-bound and interactive processes in the lower priority queues. In addition, a process that waits too long in a lower priority queue may be moved to a higher priority queue. Let's take this as an example. This is a multi-level feedback queues. The first one is Q0 is on the highest priority, and the second one is Q1. It follows the Q0 as a second highest priority, and Q2 is on the least or lowest priority. Una po, ang unang mag-execute ay ang Q0 kasi siya yung nasa pinakataas na priority, and susunod po yung Q1, siya yung sumunod, and yung pinaka last is ang Q2. Sana po tandaan natin na mag-execute lamang ang Q1, pwede lamang siya mag-execute pag empty na yung nasa taas. For example, may time quantum na 8 millisecond yung Q0. Dapat na matapos yung execution niya within 8 millisecond. Pag hindi natapos or pag hindi na complete yung execution niya, yung malilipat ang Q0 sa tail ng Q1. At saka lamang pwede mag-execute yung Q1 pag empty na yung nasa Q0. At pag yung Q1 naman, pwede na siya mag-execute at may time frame ng execution niya within 16 milliseconds, saka lamang siya pwede mag-execute. Pagtapos naman mag-execute nitong Q1, saka lamang pwedeng sumunod yung execution ng Q2. Pero pag hindi po na nag-execute completely yung Q1 within 16 milliseconds, kailangan malilipat yung nasa Q1 sa Q2. Ang Q2 naman, hindi po siya pwede mag-execute hanggat hindi nag-empty yung nasa Q1, tsaka Q2 na nasa taas niya. Kasi dahil po may scheduling algorithm po silang sinusunod. And in general, a multi-level feedback queue scheduler is defined by the following parameters: the number of queues, the scheduling for each queue, the method used to determine when to upgrade a process to a higher priority queue, the method used to determine when to upgrade a process to a lower priority queue, and the method used to determine which queue a process will enter when that process needs service. Thank you.